In this video, we're going to learn about absolute value. Now, you've likely seen the absolute value sign, that's these extra little bars here around x before. And usually when you first learn about absolute value, what it means to you is you just make whatever the number x is positive. So for example, the absolute value of -3 is just 3. And then if you have the absolute value of a number that's already positive, like the absolute value of 5, it doesn't do anything, it just keeps it as 5. And that's the initial way a lot of people learn about absolute value, is just take it and whatever it is and make it positive. There are some problems with thinking about it this way. For example, what happens if I put negative absolute value of 5? You might say, well, if there's an absolute value, everything has to be positive no matter what. But it turns out that the final answer here would be -5, because the absolute value would apply first, would make the number positive, and the negatives outside of it would be applying second by order of operations, and the result is -5. You also have more interesting examples, like what happens if you have the absolute value of x minus 3. I see a lot of times students will say this is x plus 3, and it turns out that is completely and totally incorrect. So thinking about absolute value as just take whatever's inside and make it plus doesn't always work out so well for the more advanced problems. The second way that you'll see in textbooks often is that absolute value indicates how far you are from 0 on the number line. So we said the absolute value of -3 was 3, and that was because if you're at -3, you are 3 units or 3 distance away from 0. This does have some applications for when it'd be useful to think of it this way. However, most of the time you don't want to try to draw a number line, and even worse, how are you going to draw absolute value x minus 3 on the number line if you don't know what x is? So it's also not the best way to look at it. This third way is the best way to look at absolute value in mathematics. Unfortunately, it's a bit complicated. It involves this piecewise definition here with the curly bracket. And what it says is the absolute value of some number is just equal to that number without any modification if that number is positive. And the absolute value of a number is equal to the opposite or the negative of that number if that number is negative. So for example, the absolute value of -3, we say, do we use the top rule or the bottom rule? Well, we'd use the bottom rule because it's negative. So it's going to be the opposite of that number. And the absolute value of -3 is 3. And once you have this, you can actually then finally do the absolute value of x minus 3. It is either going to be x minus 3 if x minus 3 is positive, or it's going to be the opposite of x minus 3 if x minus 3 is negative. So it at least gives us some way to work with it, even if it's a bit messy and complicated to deal with. Now, when we have absolute values, we're often going to have absolute value equations or inequalities to solve. So let's go through the process here. If you have an absolute value equation, the first thing you want to do is get the absolute value by itself. So we can go ahead, add 1 to both sides here. Then we can divide by 5. Now I will say that some people like distributing here, but you have to be very careful when you distribute with an absolute value sign, and I prefer, for myself at least, not even try to do it. Basically the trick is you can distribute a positive number in, but you cannot distribute a negative number in. So regardless, once you get to the point where you have the absolute value equals a number, well, at that point in time, we know what the absolute value is, either the same as the expression you have, or it's the opposite of that expression. So that means we either have the 2x minus 3 is 7, or we have the 2x minus 3 is -7. And then this one, if you add 3 divided by 2, you get 5. And this one, if you add 3 divided by 2, you get -2. And so our two answers here are x is 5 or x is -2. For the second one here, they already gave us the absolute value by itself, so we can go straight to splitting this up to saying either x squared plus 5x is 6, or x squared plus 5x happens to be negative 6. And then this would give me x squared plus 5x minus 6 is 0. I can factor that as x plus 6, x minus 1. I get the answers negative 6 and positive 1. But then I can also do the second one here. X squared plus 5x plus 6 is 0. X plus 2, x plus 3. And I get 2 more answers. And so it turns out that this problem actually has 4 solutions to it. I will give you a warning now, though. Absolute value equations are one of the types of equations where your method will sometimes mess up here, and you really want to double check that all these answers will work. Okay. Next up, we have absolute value inequalities. And there's basically 2 situations. Either you're going to have absolute value less than a number or absolute value greater than a number. So this is a less than problem here. And when you go to less than, you're going to rewrite this as 3x minus 2 is less than 7, and 3x minus 2 is greater than negative 7. So we need the number to both be less than positive 7 and greater than negative 7. Whenever you have any absolute value less than a number, this is how it works. You rewrite the problem by removing the absolute value signs. Then you rewrite the first part, flip the less than to a greater than, and flip the positive to a negative. Then we go ahead and solve each one of these separately. Add 2. Divide by 3, so we have x is less than 3, and add 2, negative 5, divide by 3, negative 5/3. So on my number line, I need to be smaller than 3, as well as greater than negative 5/3. So my overlap is in the middle here. My answer would be parentheses, negative 5/3 to 3, and parentheses, and that would be your answer. So again, if you have absolute value less than a number, you rewrite the inequality without the absolute value, then you put an and sign, then you rewrite it with a greater than negative number, and that's what you get. This next one looks like it's also a less than, but it's actually not, because you always have to get the absolute value by itself first. So I would have negative absolute value x plus 5 is less than negative 1. Then when I divide both sides by negative 1 here, I get the absolute value x plus 5 is greater than 1. So that means this is actually an absolute value greater than a number 1. And so what you do for this one is you remove the absolute value signs, and then you're going to put an or instead of an and. So one time I had a student tell me that they remember this as less than, less and instead of greater, they put great or. I don't know if that helps you remember which one is or and which one's and, but regardless, you need to remember that. And then you do the same thing where you flip the inequality and flip the sign to minus. And so we'd have x is greater than negative 4, or x is less than negative 6. So on our number line, we're either to the right of negative 4 or to the left of negative 6. So our answer would be negative infinity, negative 6, union negative 4 to positive infinity. In this last example here, I went ahead and did one that was a little strange with that 0 on the right-hand side. Now this is an absolute value greater than. You could go ahead and kind of repeat what we just did for B. But if you take a moment and you stop and you think about this, it says the absolute value of something, whatever 7x minus 3 is greater than or equal to 0. Well, absolute values, no matter what, are always greater than or equal to 0. And so what that means is no matter what x you plug in, it's going to be true. So therefore, all real numbers are going to be the solution. Now if you don't like that, again, you can go through the same way we just did over here. And you look at your number line, you're going to see that every single number is shaded. Therefore, the answer is negative infinity to positive infinity.